Welcome to another episode of the Pharmaceutical Calculations Solve Along. So if you're in pharmacy school, then one of the things you actually need to be able to do is completely understand the different ways of expressing concentration. Now, there are several ways. You have percentage strengths, you have ratio strengths, you have parts per million, that's ppm, parts per billion, which is ppb, and even for percentage concentrations, depending on the nature of the solute and the solvent, you have different types. You have three different types. You have percentage weight in weight, you have percentage volume in volume, and you have percentage weight in volume. So in your previous video, we looked at 6 very good examples of percentage weight in weight calculations, and the feedback was really good. So today we'll be looking at classic examples of percentage strength calculations, but this time of the weight and volume nature. All right, so if you are watching this live, then you can be sure to ask your questions in the chat box. I'll answer them when I see them. But if you happen to be watching the replay, then just leave your questions in the comments and I'll get to them as soon as I see them. So let's get right to the first question. So here the question says, how many grams of sodium citrate are contained in 60 milliliters of 22.5% weight by volume sodium citrate solution? So the way this will work is we're going to spend some time to really analyze the questions, and then we'll go ahead and solve the problem. So once again, if you have any questions, just ask them in the chat or leave them in the comments and I'll get to them as soon as I see them. The first thing we want to do is actually remind ourselves of the definition of percentage weight in volume. Okay, percentage strength when you have weight in volume. And the classic definition for that is the number of grams of your solute in 100 milliliters of preparation. So this is very important for you to recall if you've forgotten, and also to keep stenciled in your mind for the future. So the first thing we want to do is interpret what this 22.5% actually means, okay? And then we'll see how many grams contained in the 60 milliliters. So when you have 22.5%, it implies that you have 22.5 grams of the sodium citrate in a 100 milliliter preparation. That's what that means. And so since we only have 60 milliliters, then we need to determine how many grams are actually present in the 60 milliliters as opposed to the 100. Okay, so now we have a very nice proportion, and we can go ahead and simply solve for our unknown, which is x here. So x equals 22.5 grams times 60 milliliters divided by 100 milliliters. So we can do the math and we end up with 13.5 grams. So notice what just happened here. We actually made use of the definition of percentage strength, weight in volume. So 22.5% gave us grams per 100 milliliters, 22.5 grams per 100 milliliters. And then we set up a very nice proportion to find out how many grams would be in the 60 milliliters, and then we do the math. So this is a very good question, and it's more of the easier versions that you're likely to see maybe on your exam or sometime in practice. But then let's see what the next question actually looks like. So this next question actually says, to control epilepsy, a patient is prescribed 125 milligrams of phenytoin, right, to be taken 3 times a day for a week. How many milliliters of 2.5% weight by volume or weight in volume of phenytoin suspension should be dispensed for this prescription? All right, so if you compare this question to the previous one or the earlier one, it has some similarities, but there's just one added layer of complexity. Okay, so the piece that we want to unravel is what is happening with the dosing regimen. So it's taken 3 times a day for 1 week. Okay, now we need to identify what our percentage concentration is. It's 2.5% weight by volume, so we know that from here. And the question is how many milliliters. So we are looking for volume this time. All right, and so the way it is we need to determine, first of all, how many grams that the patient is actually going to take or need for this dosing regimen. Okay, that's the kicker here. All right, so the way we do that is we start off with the 125 milligrams, because that's basically what the patient needs to take. But the patient is taking it 3 times a day. So we do 3, we can do 3 times in 1 day. And we need it for a week. The week is coming from here. So 1 week, but our dimensions are not consistent. So we need to deal with that. So 1 week is basically 7 days. So this can cancel out, the weeks can cancel out, and your days can cancel out. Okay. And so eventually what ends up happening is this patient is going to require 25 milligrams of phenytoin. All right. Now we need to do one more step before we move to the actual proportion, and that has to do with the units here. So these are in milligrams. Now, if we recall, the definition of percentage strength is grams in 100 milliliters. So we want to convert the milligrams to grams, and then that would make our computation fairly straightforward. So we call that 1,000 milligrams make up 1 gram. The milligrams cancel out, and you end up with essentially 2.625 grams. So what we just found actually is the total amount patient needs in grams. That's what we just did. But the question asks for milliliters. So we need to make use of this percentage concentration information. So we take the 2.5%, which means you have 2.5 grams of phenytoin in 100 milliliters of preparation. How many milliliters will we need for the 2.625 grams? That is the question. Okay. So we solve for X, which is our unknown here. And so X is going to be equal to 100 milliliters times the 2.625 grams divided by 2.5 grams. And that gives us 105 milliliters. All right, so that is the answer to that question. Now, I don't see any questions in the chat box, so perhaps that is a good thing. Now, if you have any questions, just leave them in the chat box or leave them in the comments, and I would answer them as soon as I see them. All right, good stuff. So let's go ahead and take a look at the next question. So the questions get a little bit more complex in some ways as we move ahead. And so you may just want to move along with the pace, and then you're able to do for yourself what you need to get a better understanding of this type of a topic. All right, but let's look at this question. This question says, how many liters of a 1.5% weight by volume potassium nitrate solution can be prepared from 22 grams of potassium nitrate? So here we are still looking for volume. Okay, we're looking for the volume of the preparation. So how many liters? And we've been given the percentage concentration. All right. Now there's a phrase here which says can be prepared from, and that would help us understand how your proportion will look like. Okay, so just keep an eye on this phrase so that if you see it in the future, you know how your proportion would look like. But to start off, we make use of the percentage concentration. So 1.5% indicates you have 1.5 grams of potassium nitrate in 100 milliliters. Now, what we need to do is determine how many milliliters we will get from the 22 grams. Okay. So how many milliliters would we get from 22 grams? So that whenever we see prepared from, then typically that value goes in the numerator. All right. So we have X equals 22 grams times 100 milliliters divided by 1.5 grams. And this gives us essentially 1466.67 milliliters according to my calculator. Now we can't stop here because the answer should be in liters, so we need to do a quick conversion. So we go ahead and make use of the conversion factor that 1,000 milliliters gives us 1 liter. The milliliters cancel out and we end up with 1.47 liters. Okay, so that's how you solve this question. Let's take a look at the next question. So here you actually have a prescription, and in this prescription you have glycerin, resorcinol, and so on. All right. Now the question is asking for how much glycerin and resorcinol, which is a solid, are needed for this prescription. So we will go ahead and basically determine that, and we start with the glycerin. So for glycerin, we have 12%. But 12% of glycerin implies that you have 12 grams of glycerin in 100 milliliters. Now for this prescription, we need to determine, actually glycerin is in milliliters, so this value right here should be 12 milliliters. Okay, so 12 milliliters out of 100 milliliters, this should be equal to some volume in milliliters over the quantity of the preparation. Now here we have 6 floral ounce, which means that we need to convert the floral ounce to milliliters for this proportion to actually work. All right, so we will do that conversion here. So 6 floral ounce, basically 1 ounce is 30 milliliters. So the ounces cancel out, and that gives us 180 milliliters. All right, so we can basically rewrite this proportion again, and we will have 12 milliliters divided by 100 milliliters being equal to some quantity divided by 180 milliliters. We can now go ahead and solve for our unknown, which is X here. So X equals 12 milliliters times 180 milliliters divided by 100 milliliters. So we can go ahead and solve for our unknown here. And so X is going to be equal to 21.6 milliliters. Okay. All right. Good stuff. The next thing we can do is we can do the same thing for the resorcinol. And the way we want to do that is basically to repeat the process. But this time we know what the volume is. The total volume is actually 180 milliliters. So we will take this percentage concentration, which is 3.5, and we'll do 3.5 grams of resorcinol in 100 milliliter preparation. And we need to determine how many grams is actually in the 180 milliliters. Now, the way we know it's grams is because it says it's a solid, so that's the units that go with it. So we can go ahead and solve for y, which is our unknown, and y is going to be equal to 3.5 grams times 180 milliliters divided by 100 milliliters, and that will give us 6.3 grams. All right, so these are some really good questions. We have a couple more to go and then we are done. Now, this question is quite tricky for some people, and we'll soon find out how easy it can be once you know what you're doing. So here you have your prescription with hydrochloric acid. You have 10% weight by volume, and you're making 60 milliliters, and your instructions is to take 15 drops in water. So the question is asking how many grams of hydrochloric acid, or HCl, does the patient receive in each dose if the dropper dispensed with this medication delivers 32 drops per milliliter. So here the trick actually is we need to know, for us to be able to use the 10% weight by volume information, we need to understand what the drops would be in terms of milliliters. So the first task here is actually to convert the drops to milliliters. And the way we do that is to make use of this conversion factor. All right, so we will take 32 drops, which is in 1 milliliter, and we'll determine what that will be for in milliliters if you have 15 drops. So we put the x in our denominator here. Now we can solve for the unknown. So x is going to be equal to 15 drops times 1 milliliter divided by 32 drops. And this gives us 0.47 milliliters. Now this was an important step, a very important step, because we will need to use this volume to determine actually the quantity. So for that next step, we need to make use of the percentage concentration information here. And so 10% implies you have 10 grams of hydrochloric acid in 100 milliliters of preparation. And we want to determine how many grams will be in the 0.47 milliliters. So now at this point, we can go ahead and solve for x, which is for y, which is our unknown. So y equals 10 grams times 0.47 milliliters divided by 100 milliliters. The milliliters cancel out, and you essentially end up with 0.047 grams. So the trick here was actually to know, to be able to convert the drops to milliliters. So you need to convert drops to milliliters so that you can make use of the percentage concentration. And then that's what we did here using the proportion, and then we end up with this answer. So that was a very, very important step here, converting drops to milliliters. So we are almost there. We have just one more question and we'll be done for this particular session. So this question gives you the elixir for phenobarbital. It says you have 120 milliliters, and then you have 1 teaspoon 3 times a day. That's what it's saying. So the question actually begins, elixir phenobarbital contains 0.4% phenobarbital weight by volume. How many milligrams, key point, of phenobarbital does the patient receive each day? Another key term. All right, so when it says each day means we need to first of all understand how much the patient is getting. So the strategy here will be to determine the total volume that the patient takes in a day, and then use that in conjunction with the percentage concentration to determine the amount in grams and then ultimately in milligrams. So those are the basically 3 steps. So that's the logic to your solution. So let's start off with the volume here. So it's 1 teaspoonful and it's 3 times a day. So 3 times per day. And basically we are interested in what the patient will get each day. So 1 day. So at this point the days cancel out. Now we are still in teaspoonful. We need to convert the teaspoonful to milliliters. So 1 teaspoonful is basically 5 milliliters. So this ends up giving us 15 milliliters volume. That's what the patient will take each day, that volume. Okay. So now we need to find out the quantity in grams of phenobarbital that is present in the 15 milliliters. So we start off with the percentage with the 0.4 grams of phenobarbital in 100 milliliters, and we need to determine how many grams would be in 15 milliliters. So we go ahead and solve for x, which is our unknown. X is going to be equal to 0.4 grams times 15 milliliters divided by 100 milliliters. And this actually gives us 0.06 grams. But we don't stop here because we need the answer in milligrams. All right. So we need to do one more step, which is a quick conversion. And we make use of the conversion factor. 1 gram is equivalent to 1,000 milligrams. The grams cancel out. And this gives us 60 milligrams. So we just went through 6 classic weight and volume percentage strength calculations. These are some of the most common ones you are likely to see or should be able to do based on your experience in pharmacy school and beyond. And I'm hoping you found them useful. If you did, just be sure to give the video a like or share it so that some of your colleagues can also benefit from it. So I don't see any questions in the chat yet, and I don't see any comments as of now. So if you happen to watch this video later and you have questions, just put them in the comment section and I will address them as soon as I see them. So my work here is done for now, but yours has just begun, and I will see you in the next video.